You ever see one of those AI demos that just completely blows your mind? You try it yourself, all excited, and then it's just meh. You are definitely not alone. There is this huge, super frustrating gap between what AI agents promise and what they actually deliver. So let's get into why that is. It's a story we've all experienced, right? You ask an AI to do something that seems pretty simple, like, hey, plan a trip with a few stops, or summarize this long email chain and pull out the action items. And it starts off great, super confident, but then it just gets lost, forgets what it was doing, and kind of gives up. Which brings us to the big question here. Why are these incredibly powerful models? I mean, they're trained on pretty much the entire internet. Why do they get tripped up by any task that needs more than just one single step? What is going on? And this slide, this just captures it perfectly. Over on the left, you've got the demo. It's this flawless genius, handling a super complex task like it's nothing. But then on the right, you have the reality, which is what we all actually live with. It gets confused after step one, totally loses the plot, and just quits. The promise and the reality, they're not even in the same universe. So to really understand why this happens, we have to pop the hood and look at how these things are built. Because the problem, it turns out, isn't about how much data they have, it's about how they fundamentally think. And here it is, the core of the issue. Today's large language models, they don't actually reason, they react. They are absolutely incredible at predicting the next word in a sentence. They generate this beautiful, fluent text by just reacting to whatever came before. But they don't plan, they don't reflect, and they don't change their strategy. They are reactive, not proactive. This analogy here is just perfect. Think of a current LLM as a brilliant improv actor. They can come up with an amazing line based on what the other person just said, but they have absolutely no script, no idea where the story is actually going. What we need is a film director, an AI that has a plan, that can see when a scene isn't working and can reshoot and adjust to make sure it hits that final goal. So how do we get from the improv actor to the film director? Well, researchers are looking at a really fundamental shift in how we build these systems. We have to move away from simple reaction to something called agentic reasoning. This right here is the whole idea. Agentic reasoning isn't just some new feature. It's a complete change in what we think an AI even is. It's about turning the AI from a passive text machine into an active autonomous agent. It's no longer about just answering a prompt. It's about planning, acting, and, this is the most important part, learning from the results. So instead of thinking in a straight line, an agentic AI works in a continuous loop. First, it observes the situation. Then, it makes a plan. It takes an action. And then, and this is the absolute game changer, it reflects on the outcome. Did that work? Why or why not? Then it updates its own understanding and tries again, literally getting smarter with every single cycle. Okay. Now, I know this diagram looks a little complex, but just focus on that one key part. You see that section labeled self-evolving? That feedback loop, that is the engine of intelligence. The ability to look back at its own actions, make a new plan, and update its memory, that's what turns a simple reactor into a genuine reasoner. It's how it learns from its mistakes instead of just making them over and over again. So how do you actually build one of these things? Well, it's not just one trick. It's more like a stack of capabilities, which the research paper breaks down into 3 different layers. The first layer is the bedrock, the foundation. This is where the agent takes a big, messy goal and breaks it down into a concrete plan, a series of smaller, doable steps. It's about having the smarts to map out the whole journey before you even take that first step. Now, layer 2 is where it gets really, really cool. This is self-evolution. The agent actually uses feedback, whether that's just reflecting on its own mistakes or getting a success signal from an external tool to get better. It learns from experience, and it can adapt its whole strategy without needing to be completely retrained from scratch. And then at the very top, you've got collective reasoning. And this is the future. Instead of one AI trying to do everything, you have a whole team of specialized agents. One might be the coordinator, another does the heavy lifting, and a third acts as a critic, checking the work. This kind of collaboration lets them tackle problems that are way too complex for any single agent to solve alone. Okay, so what does this all add up to? What does this mean for the future of AI? Well, it points to a completely different path forward than the one a lot of folks are on right now. This quote, right here, this is probably the most important takeaway of this whole thing.
Agentic reasoning isn't just another neat feature you add on. It's the fundamental architecture. It's the missing operating system that lets a powerful LLM brain actually think and act reliably in the real world.
And that leads to a pretty tough conclusion for the entire AI industry. The current strategy of just make the models bigger, feed them more data, well, it's hitting a wall. When it comes to making agents that you can actually rely on, just scaling up isn't working anymore. Piling on more words doesn't magically lead to better decisions. So the real path forward, it seems, is all about architecture, not just scale. It's about building systems that are smart enough to separate thinking from doing, systems that have self-correction and reflection baked right in. It's about building truly intelligent systems, not just bigger and bigger prediction models. So I guess I'll just leave you with this final thought to chew on. What if the next huge leap in AI isn't about building a bigger brain at all, but about finally designing a much smarter architecture for that brain to live inside?